For any homework-related queries, call us at +1 678 648 4277. You can mail us at info@statisticshomeworkhhelper.com or reach us at https://www.statisticshomeworkhelper.com. 1. Regression through the origin for bivariate data on n cases, 11e, I equals 1, 2, n. Consider the linear model with zero intercept. E equals xi plus ei, I equals 1, 2, n. Where ei are independent and identically distribution n, 0 is sigma 2, random variables with fixed, but unknown variance sigma 2, 0. When 11 equals 0, then 11 beta equals 0. A. Solve for the least squares line, y equals beta x. B. Find the distribution of beta, the slope of the least squares line. C. What is the distribution of the sum of squared residuals from the least squares fit? D. Find an unbiased estimate of sigma 2 using your answer to C. Solution: A. Set up the regression model with vectors/matrices. statisticshomeworkhelper.com. And beta sadface beta, y equals x beta plus e. The least squares line minimizes the least squares estimate beta solves the first order equation, equals 0 del beta and is given by the least squares line is distribution, and all we need to do is compute the expectation and variance of beta. statisticshomeworkhelper.com. C. For a normal linear regression model, the distribution of the sum of least squares residuals has a distribution equal to sigma 2, the error variance, times a chi-square distribution with degrees of freedom equal to n minus p, where p is the number of independent variables and n is the number of cases. In this case, p equals 1, so statisticshomeworkhelper.com. D. Since a chi-square random variable has expectation equal to its degrees of freedom, ser equals sigma 2, n minus 1, so is an unbiased estimate of sigma 2. 2. Simple linear regression. Consider fitting the simple linear regression model, y equals beta 1 plus beta 2 11 to the following bivariate data. The following code in R fits the model, statisticshomeworkhelper.com. X equals C-5-2-3-4, Y equals C-20-3-5, plot, X Y, LMFIT 1 LM, YX, abline, LFIT 1, print, summary, LMFIT 1. Call, LM, formula equals YX. Residuals, 12340.11111 minus 0.05556 minus 0.66667 0.61111. Coefficients, estimate STD, error t-value PRT. Intercept, 1.50000 0.32275 4.648 asterisk x 0.72222 0.08784 8.2220.0145 asterisk underscore signif. Codes 0 asterisk 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 0.001 asterisk asterisk 0.01 asterisk 0.05 dot 0.11. Residual standard error 0.6455 on 2 degrees of freedom multiple r squared 0.9713 adjusted r squared 0.9569 f statistic 67.6 on 1 and 2 df p-value 0.01447. statisticshomeworkhelper.com. A. Solve directly for the least squares estimates of the intercept and slope of the simple linear regression. Obtain the same values as in the R. Print summary. statisticshomeworkhelper.com. Solution. The least squares estimates are given by plugging in we get. B. Give formulas for the least squares estimates of beta 1 and beta 2 in terms of the simple statistics. statisticshomeworkhelper.com. Solution. We know formulas for the least squares estimates of the slope and intercept are given by C. In the R print summary, the standard error of the slope beta 2 is given as sigma equals 0.0878 beta 2 using sigma equals 0.65. Give a formula for this standard error using the statistics in B. statisticshomeworkhelper.com. Solution. We know that the variance of the slope from a simple linear regression model, where the errors have mean 0, constant variance sigma 2 and are uncorrelated is. The standard error of beta 2 is the square root of this variance, plugging in the estimate sigma for the standard deviation of the errors. D. What is the least squares prediction of y when x equals 0, and what is its standard error, estimate of its standard deviation? Solution. The least squares prediction of y when x equals x must be y, the mean of the dependent variable. The simple least squares regression line always goes through the point of means, x, y equals x, y. The standard error of this prediction is just the estimate of the standard deviation of the sample mean y, which is 3. Suppose that grades on a midterm and final have a correlation coefficient of 0.6 and both exams have an average score of 75 and a standard deviation of 10. statisticshomeworkhelper.com. A. If a student's score on the midterm is 90, what would you predict her score on the final to be? B. If a student's score on the final was 75, what would you guess that his score was on the midterm? C. Consider all students scoring at the 75th percentile or higher on the midterm. What proportion of these students would you expect to be at or above the 75th percentile of the final? I. 75%, 2. 50%, 3. Less than 50%, or 4. More than 50%. Justify your answers. Solution. A. Let x be the midterm score and y be the final score. The least squares regression of y on x is given in terms of the standardized values.